Incandescent lamps are less tolerant of voltage fluctuations than fluorescent lamps in terms of lumens output. As voltage drops, the current through the filament decreases, causing the filament to cool and emit less light. This results in a reduced lumens output. However, the reduction in light is not as pronounced as in fluorescent lamps. Overvoltage increases a current flow through the filament, which can cause the filament to overheat and fail prematurely. The lifespan of the lamp is significantly reduced with overvoltage. Fluorescent lamps are more tolerant of voltage fluctuations than incandescent lamps. Fluorescent lamps require a specific amount of voltage to start and operate efficiently. Voltage drops can cause the lamp to flicker or even fail to start. Small voltage drops, say 5 volts to 10 volts, usually do not have a significant impact on lumens output, but larger drops can cause noticeable dimming. Fluorescent lamps are designed to operate within a specific voltage range. Overvoltage can cause the ballast, which regulates the voltage and current flow, to overheat and fail, leading to lamp failure. Overvoltage can also cause the phosphor coating inside the lamp to degrade more quickly, reducing the light output. Fluorescent lamps are more sensitive to voltage drops than incandescent lamps. They may dim or fail to start at low voltages. Incandescent lamps are more susceptible to damage from overvoltage than fluorescent lamps. Overvoltage can shorten the lifespan of incandescent lamps and cause filament failure. Therefore, if voltage fluctuations are a concern, fluorescent lamps are a more tolerant choice than incandescent lamps, particularly in situations where voltage drops are common. To elaborate further, consider the specific mechanisms at play within each type of lamp. Incandescent lamps produce light by heating a filament until it glows. This process is highly dependent on the voltage applied. The relationship between voltage and light output is not linear. Even small voltage changes can lead to significant changes in light output. For example, a 5% voltage drop might result in a 20 to 30% reduction in light output. Additionally, the color temperature of the light also changes with voltage fluctuations. Low voltage results in a warmer, more yellow light, while higher voltage produces a cooler, more white light. This color shift can be noticeable and undesirable in some applications. The lifespan of an incandescent lamp is also significantly affected by voltage fluctuations. Overvoltage, even for short periods, can dramatically shorten the lifespan of the filament, leading to premature failure. Undervoltage, while not as immediately damaging, can still reduce the lamp's efficiency and overall light output. Fluorescent lamps, on the other hand, operate on a different principle. They use an electric arc to excite mercury vapor, which then emits ultraviolet light. This ultraviolet light is converted into visible light by a phosphor coating on the inside of the lamp. The operation of a fluorescent lamp is regulated by a ballast, which controls the voltage and current supplied to the lamp. The ballast plays a crucial role in mitigating the effects of voltage fluctuations. While fluorescent lamps are more tolerant of voltage fluctuations than incandescent lamps, they are not immune to their effects. Voltage drops can cause the lamp to flicker or fail to start. This is because the ballast requires a minimum voltage to initiate and sustain the electric arc. Once the lamp is operating, small voltage drops may not have a significant impact on light output, but larger drops can cause noticeable dimming. Overvoltage can also damage fluorescent lamps. The ballast is designed to operate within a specific voltage range, and exceeding this range can cause it to overheat and fail. Additionally, overvoltage can accelerate the degradation of the phosphor coating, reducing the lamp's light output and lifespan. In summary, while both types of lamps are affected by voltage fluctuations, incandescent lamps are generally more sensitive. Incandescent lamps experience a more pronounced reduction in light output with voltage drops and are more susceptible to damage from overvoltage. Fluorescent lamps, with their ballast-regulated operation, are better able to tolerate voltage fluctuations, but they can still be affected by extreme voltage variations. When choosing between incandescent and fluorescent lamps, it's important to consider the potential for voltage fluctuations in the application. In areas with stable voltage, incandescent lamps may be a viable option, especially if color rendering is a critical factor. However, in areas with frequent voltage fluctuations, fluorescent lamps are a more reliable choice due to their greater tolerance. Moreover, Newer lighting technologies like LED lamps offer even better performance in terms of voltage fluctuation tolerance and energy efficiency. LED lamps are designed to operate over a wide voltage range and are less sensitive to voltage variations than either incandescent or fluorescent lamps. This makes them a more robust and reliable option for applications where voltage fluctuations are a concern. In addition to considering the type of lamp, it's also important to ensure that the electrical system is properly designed and maintained. Proper wiring, grounding, and voltage regulation can help minimize voltage fluctuations and ensure that lamps operate within their specified voltage range. This can extend the lifespan of the lamps and improve the overall performance of the lighting system. In conclusion, when dealing with voltage fluctuations, understanding the characteristics of different lamp types is crucial. Incandescent lamps are highly sensitive to voltage variations, while fluorescent lamps offer better tolerance due to their ballast-regulated operation. However, LED lamps provide the best performance in terms of voltage fluctuation tolerance and energy efficiency. By carefully considering the application and the potential for voltage fluctuations, it's possible to choose the right lamp type and ensure reliable and efficient lighting performance. Furthermore, when analyzing the effects of voltage fluctuations on lighting systems, it's essential to consider the specific characteristics of the electrical grid and the load profile of the building. In areas with weak electrical grids or high load variations, voltage fluctuations may be more frequent and severe. In such cases, it's particularly important to choose lamps with high voltage tolerance and to implement voltage regulation measures. Voltage regulation can be achieved through various methods, such as installing voltage stabilizers or using constant voltage transformers. These devices help maintain a stable voltage supply to the lighting system, minimizing the effects of voltage fluctuations on lamp performance and lifespan. In addition to voltage regulation, it's also important to consider the impact of harmonic distortion on lighting systems. Harmonic distortion is a phenomenon that occurs when nonlinear loads, such as electronic devices and some types of lighting ballasts, draw current in a non-sinusoidal manner. This can create voltage distortion on the electrical grid, which can negatively affect the performance of lighting systems. Harmonic distortion can cause lamps to flicker, overheat, and fail prematurely. To mitigate the effects of harmonic distortion, it's important to use lighting equipment with low harmonic distortion characteristics and to implement harmonic filtering measures. Harmonic filters are devices that reduce the amount of harmonic current flowing on the electrical grid, improving the voltage quality and reducing the stress on lighting systems. Moreover, the choice of wiring and cabling can also influence the performance of lighting systems under voltage fluctuation conditions. Undersized or poorly installed wiring can exacerbate voltage drops, leading to dimming and premature failure of lamps. It's important to use properly sized wiring and to ensure that all connections are tight and secure. Additionally, the use of shielded cables can help reduce electromagnetic interference, which can also affect the performance of lighting systems. Furthermore, the use of lighting control systems can also help mitigate the effects of voltage fluctuations. Lighting control systems can automatically adjust the light output of lamps to compensate for voltage variations, maintaining a consistent level of illumination. These systems can also dim lamps during periods of high voltage, reducing energy consumption and extending lamp lifespan. In addition to these technical considerations, it's also important to consider the economic aspects of lighting system design. The cost of lamps, ballasts, wiring, and control systems can vary significantly, and it's important to choose the most cost-effective solution that meets the performance requirements of the application. A life cycle cost analysis can help evaluate the total cost of ownership of different lighting systems, taking into account factors such as energy consumption, lamp replacement costs, and maintenance costs. By considering both the technical and economic aspects of lighting system design, it's possible to create a lighting system that is both reliable and cost-effective. In conclusion, voltage fluctuations can have a significant impact on the performance and lifespan of lighting systems. By understanding the characteristics of different lamp types, implementing voltage regulation measures, mitigating harmonic distortion, using proper wiring and cabling, and utilizing lighting control systems, it's possible to minimize the effects of voltage fluctuations and create a lighting system that is both reliable and efficient.